Welcome back for another deep dive from Peaceful Rooster Experience. This time we're getting hands-on with the tech behind those apps you use every day. You know the apps that handle millions of users without breaking a sweat?
Yeah, they're everywhere now.
We're talking about APIs and API gateways, those behind-the-scenes heroes of the tech world.
It's fascinating, isn't it? You order food online, book a ride, or just check the weather.
Yeah,
All of that relies on communication between different parts of the application, and that's where APIs come in.
right. I've seen some of those code examples you pulled for this.
Oh, yeah.
This fast API snippet in Python, it's surprisingly readable.
It really is.
It almost looks like you're defining a digital restaurant menu. Here's an item with a name and a price, and now I can access it with a simple endpoint.
That's the beauty of well-designed APIs. Just like a menu, they need clear documentation so developers know how to interact with them. But unlike a static menu, APIs are dynamic. You've got those HTTP methods, GET, POST, and so on, that let you perform actions like adding new items or updating existing ones. It's like having a conversation with the application.
Oh, so kind of a back and forth.
Exactly.
And I see this API key mentioned in the code. Is that part of the authentication I keep hearing about, like making sure only the right people can access the menu, so to speak?
Precisely. Security is crucial, especially with sensitive data. An API key is just one way to control access.
So it's kind of like a password?
Yeah, you can think of it like that.
Okay, cool.
But when your app starts to scale and you want to ensure a smooth user experience, even with a ton of traffic, that's when you bring in the big guns, the API gateway.
Okay, I'm picturing a super organized traffic cop directing requests and making sure everything flows smoothly.
That's a great analogy.
What happens when you have a flash sale and suddenly thousands of users are trying to access your app at the same time? Does the gateway just not freak out?
Not at all. A robust API gateway is built to handle those situations. It can distribute traffic across multiple servers using a technique called load balancing. Think of it as having multiple chefs in a kitchen, each handling a portion of the order so that no one gets overwhelmed.
So it's like teamwork for servers.
Exactly. Many hands make light work, as they say.
But even with the best chef team, sometimes things go wrong. Outages happen, servers crash, and users are left staring at error messages. How do you build a system that can withstand those kinds of failures?
That's where high availability comes in. One of the key principles is redundancy, having backup systems in place, so if one part fails, another can seamlessly take over. And then you've got tools like Kubernetes, which can orchestrate all of this automatically. It's like having a self-healing system that can recover from problems without any human intervention.
Kubernetes.now, that's a name that keeps popping up in these articles, and there's a Docker Compose example too, showing how you can basically define your entire system in code and spin up new instances with a few commands. It almost sounds too easy.
Well, don't be fooled by the apparent simplicity. There's a lot of complexity hidden beneath the surface. For example, when you're dealing with distributed systems like this, you run into a fundamental challenge, the CAP theorem.
Ooh, a theorem.
It states that you can only guarantee 2 out of 3 desirable properties: consistency, availability, and partition tolerance.
Okay, let's break this down.
Sure.
Consistency means everyone sees the same data at the same time.
Right.
Availability means the system is up and running even if part of it fails.
That's right.
And partition tolerance means it can handle network disruptions. So it's like a choose-your-own-adventure for system design.
Right. Precisely. And the choices you make depend heavily on the needs of your application. For instance, if you're building a financial system, consistency might be your top priority. You absolutely need to ensure that every transaction is reflected accurately across all servers.
Yeah, that makes sense.
But if you're building a social media platform, you might prioritize availability, accepting the possibility of temporary inconsistencies to ensure users can always access the service.
So different apps, different priorities, different trade-offs.
Exactly.
It makes you realize how much thought goes into designing these systems that we often take for granted.
Absolutely. It's a lot more than meets the eye.
Speaking of design, there's one more big piece of the puzzle we need to talk about: REST.
REST. It's a widely adopted architectural style for building web services, and it's all about simplicity and scalability. REST APIs are stateless, meaning each request contains all the information needed to process it. You don't need to remember previous interactions, which makes it easier to distribute requests across multiple servers.
And our trusty Fast API code seems to be a good example of REST in action, right?
Yes, it is.
It's using those standard HTTP methods like get, D, and post that you mentioned earlier.
Exactly. FastAPI makes it very intuitive to build RESTful APIs. But there's another approach gaining traction, especially when you need even more speed and efficiency: gRPC.
gRPC dot. Not, that sounds intriguing. Is it like REST on steroids?
You could say that. gRPC uses protocol buffers, a super efficient way to encode data, and it leverages HTTP2, which brings all sorts of performance enhancements to the table. If REST is a reliable family car, gRPC is a sleek sports car built for speed.
Okay, now I'm picturing a high-speed data race. But seriously, this gRPC thing seems like it has the potential to really shake things up in the API world.
It definitely does. And one of its coolest features is bidirectional streaming, which allows for real-time two-way communication between the client and server.
Oh, wow.
Imagine the possibilities for things like chat applications or real-time dashboards.
Mind blown. And I see there's a Python code snippet for a gRPC server as well. It looks a bit more complex than the FastAPI example.
Yeah, it can be a bit more involved.
But I guess that's the price you pay for all that extra speed and power.
It can seem daunting at first, but gRPC has a secret weapon: code generation. You define your service using protocol buffers, and then gRPC tools can automatically generate client and server code in multiple programming languages. This saves you time and ensures consistency and reduces errors.
Wow, so gRPC takes care of all the tedious plumbing work for you.
Exactly.
That's amazing. And with that, I think we've covered a solid foundation for building scalable systems. We've explored APIs, gateways, the challenges of high availability, the trade-offs of the CAP theorem, the simplicity of REST, and the power of gRPC.
You got it. But this is just the beginning. As we dive deeper, we'll uncover even more fascinating insights into the world of scalable systems and the technologies that power our digital lives.
Well, you've definitely piqued my curiosity. I can't wait to see what other surprises this deep dive has in store for us.
Let's keep exploring. There's a lot more to uncover, and who knows what groundbreaking innovations we might stumble upon along the way.
I'm ready when you are.
Let's do it. It's funny, we talk about all this complex technology, APIs, gateways, gRPC, but it all comes down to solving real-world problems. Making things easier and more efficient for people.
Absolutely.
Yeah.
It's easy to get lost in those technical details,
Mm-hmm.
but at the end of the day, it's about creating systems that work
Yeah.
seamlessly and reliably,
Mm-hmm.
whether it's for a global e-commerce platform
Right.
or a local coffee shop app.
And that brings us back to the CAP theorem, those tough choices we touched on earlier.
Yeah.
It's a fundamental concept that every system architect grapples with.
Oh, yeah?
You can't have it all. Consistency, availability, and partition tolerance. You have to decide which two are most critical for your application.
Right. And it's not always a clear-cut decision.
Right.
I'm looking at this example of Cassandra,
Yeah.
a NoSQL database that prioritizes availability and partition tolerance. It's designed to stay up and running even if there are network issues or server failures, but it accepts the possibility of temporary data inconsistencies.
That's a great example of an AP system. It's like saying, hey, we might have a few hiccups with the data, but we're going to make sure the system is always available. And for applications like social media or sensor networks where high availability is paramount, that can be a perfectly valid trade-off.
So it's like saying, we might miss a few likes or tweets temporarily, but at least people can keep scrolling.
Exactly.
But I imagine there are situations where consistency is non-negotiable.
Absolutely. Think about financial transactions. You can't have a system where someone's account balance is different depending on which server they happen to connect to.
Oh, right.
In those cases, you'd prioritize consistency, even if it means sacrificing some availability.
Gotcha. So it's all about understanding the trade-offs and choosing the right balance for the specific needs of your application. And that leads us back to the world of APIs and the architectural styles we use to build them. Talking about REST, which emphasizes simplicity and scalability.
Right. REST has become the dominant style for web services for good reason. It's easy to understand, it's well supported by various tools and frameworks, and it scales beautifully. But as we've seen, gRPC is emerging as a powerful alternative, particularly when performance is paramount.
And what's fascinating is that gRPC isn't just about raw speed.
Right.
It also introduces new possibilities with features like bidirectional streaming. We can suddenly build applications that communicate in real time, like chat apps or collaborative editing tools. It's like opening up a whole new dimension of interactivity.
And remember, gRPC comes with code generation, which can be a huge time saver for developers.
Yeah.
You define your service using protocol buffers, and then gRPC tools take care of generating the boilerplate code for client and server communication. It's like having a personal assistant that handles all the tedious work for you.
I'm starting to see why gRPC is generating so much buzz. It's like the future of API development,
Yeah.
offering this combination of speed, efficiency, and developer friendliness.
It's definitely a technology to watch. And as we delve deeper into these concepts, we'll uncover even more exciting possibilities and explore how they're shaping the future of software development. You know, one thing that struck me while reviewing these source materials?
What's that?
Well, we've been talking about all these technical details, but there's a human element to this as well.
Oh, okay.
Building scalable systems is about more than just choosing the right technologies.
Yeah.
It's about teamwork, communication, and a shared understanding of the goals and challenges.
That's a great point. You can have the most advanced tools and frameworks,
Right.
but if the team isn't aligned, the project is likely to struggle.
Exactly. That's something I think we often overlook. We get so focused on the technical aspects that we forget about the human factors that are equally important.
Right.
Building great software is a collaborative endeavor, and it requires clear communication, empathy, and a willingness to learn from each other.
I couldn't agree more. And I think that's a valuable lesson to keep in mind as we continue our deep dive into the world of scalable systems. It's not just about the technology, it's about the people behind it.
Well said. And with that in mind, let's dive into the final part of our exploration. We've laid a solid foundation, and now it's time to see how all these pieces come together to create truly remarkable systems.
As we wrap up this deep dive, it's amazing to see how all these seemingly disparate pieces fit together.
It's like we've been putting together this giant jigsaw puzzle.
Yeah.
APIs, gateways, scaling strategies, the CCAT theorem, REST, gRPC, each one a piece of the larger picture of building truly robust and scalable systems.
And what's fascinating is how these concepts are constantly evolving. We talked about REST being the dominant architectural style for web services, but now gRPC is emerging as this high-performance contender, especially with the rise of real-time applications and the need for lightning-fast communication.
Exactly. It's a reminder that the world of technology never stands still. There's always something new to learn, a new challenge to tackle, and that's what makes this field so exciting.
I'm curious, looking ahead, what are some of the trends or innovations you're most excited about in the world of scalable systems?
One area that I'm particularly intrigued by is the intersection of serverless computing and API development. With serverless platforms, you can essentially run your code without having to manage any servers.
Oh, wow.
This opens up all sorts of possibilities for creating highly scalable and cost-effective APIs.
Yeah.
Imagine deploying a new API endpoint in seconds without having to worry about provisioning servers or configuring load balancers.
That sounds like a game changer for developers.
It is.
It would free them up to focus on the core logic of their application rather than getting bogged down in infrastructure management.
Precisely. And as serverless platforms mature and become more widely adopted, I think we'll see a surge in innovation in the API space. We might even see new architectural styles emerge that are specifically tailored to the serverless paradigm.
It seems like the possibilities are endless. This deep dive has given me a whole new appreciation for the complexity and ingenuity that goes into building the systems that power our digital world.
Yeah.
It's easy to take for granted the seamless experiences we have online,
Yeah.
but there's an incredible amount of work happening behind the scenes to make it all possible.
It's true, and I think it's important to remember that the systems we've been discussing are ultimately tools. They're means to an end. And the real magic happens when we use these tools to solve real-world problems, to connect people, to create new possibilities.
Well said. So as we wrap up, what's the one key takeaway you want our listeners to walk away with?
I would say this: never stop learning, never stop exploring. The world of technology is constantly changing, and the only way to stay ahead of the curve is to embrace that change, to be curious, to experiment, and to never be afraid to ask questions.
Excellent advice. And on that note, we'd like to thank you for joining us on this deep dive into the fascinating world of scalable systems. We hope you've enjoyed the journey and come away with a newfound appreciation for the incredible technology that underpins our digital lives.
Until next time, keep learning, keep building, and keep pushing the boundaries of what's possible.
This is Peaceful Rooster Experience, signing off.